Good evening, everyone, and a warm welcome to the Apache Spark course we are starting tonight. Let me just give you a bit agenda of what we are going to discuss today. So today we will begin with some introduction to the course. So there are a couple of queries, what exactly we are going to learn, what we are going to discuss, what portion, and then how much we are going to cover, and etc. etc. So I will try to answer this. Then secondly, I'm just planning that we will begin with some introduction to the big data, which is like a very short introduction of big data and then kind of a distributed systems. Then we will somewhere go back to the history of Spark. And of course, the history of Spark cannot be completed without kind of Hadoop or Hive counterparts of it. So we will have some quick idea regarding that. And then today I'm planning that I will be able to tell you the basic setup of the Spark, very minimal level setup for the Spark to run on your machine. And once we get that, I can probably show you how to use that setup, means probably how to write a kind of a hello world kind of application. So today's lecture may not be too technically heavy, but yes, it is more of introduction. It is more of setting up the tone, getting a little bit of idea regarding how exactly this course will also go. And this should be a kind of a bit booting to the our Spark. That is something we are planning. As usual, I'm not really going to use any kind of slides as such. So you find that these slides are, as usual, the empty slides. There's nothing on these slides. So we will be using these slides over here, and we will be discussing our points one after one another over here. Correct? So the very first thing what we are going to start with is basically what is big data. Guys, should we begin? If there are no further queries, questions, or something like that. The link of the WhatsApp group is sent to your email. So kindly check your email, and from there you can join that group. If it is still not, Rahul sir can help you. Mehul, please check that. Okay. Anyway, guys, should we begin then? So we spend around 30 minutes into the introduction, the basically what exactly we are going to talk about. And someone is asking, is it related to machine learning? Not exactly. I guess you'll join little late, I guess. This course is all about the Spark, data engineering, and big data processing. We will be having one introduction to the machine learning using Spark, but then most of the course is focused on the Spark batch processing, Spark stream processing, and Spark and Kafka integration, probably some Databricks Lakehouse platform. That is something we are going to talk about, right? Yeah. Chalo. Now we can begin. The very first thing we will ask a question is something what exactly the big data is about. So people are talking about big data. People are talking about data engineering. So where exactly this story started? Now, I would say that roughly this story started somewhere in early 2000. So early 2000, where you find that internet people started using actively, and by 2000 people started exploring the internet for the business. People started talking about the social networking. People started talking about how we can reach to the different corners of the world, and probably people were looking for a lot of different possibilities. Correct? And in that whole process, the lot of data was getting generated, and then companies were thinking that whatever data is getting generated now, that data has to be processed, that data has to be analyzed, that data has to be researched. And people soon realize that whatever existing database technologies which were available by year 2000, they were not sufficient to handle this burst of the data. So somewhere in year 2000, 2001, a company known by everyone like Google started working on how this huge data can be processed. And that huge data can be processed. So companies do realize that it is very difficult to process that huge amount of data with a single machine. With the single machine, if you start processing this huge amount of data, it is going to be a tough job. So people started thinking of that how we can process this huge amount of data. And then people talk about, can I use probably multiple machines together to handle this huge amount of data? And this is where this whole big data stuff is then tightly coupled to something called as a distributed systems. But then the primary question always remain there, and people always keep talking about that what exactly the data that you start calling it as a big data. So there are like a common characteristics. I will not go into the too detail, but yes, these fundamentals still remain true, that exactly which projects or which data projects should be considered as a big data projects. So people start talking about certain characteristics of big data, and those characteristics of big data are popular by the name V's of big data. The first one, people start talking about the volume of data. And this volume of data, the traditionally at that time, people were able to manage the data of like hundreds of GBs. But moment your data was going on terabytes onwards, your data is going in a range of petabytes onwards, and nowadays even the data is going on an exabyte and onwards. At that time, it is impossible to handle this particular data with the traditional systems which are present at that particular time. So whenever you have kind of a high volume of the data, it should be considered as a big data. Then the second thing, sometimes you may not be really talking about the high volume of the data, but though you start with the small volume of data, but soon you start collecting a lot of inputs. You start collecting the huge amount of data in your system. Like for example, you talk about a cab company like Uber. Now, Uber kind of company, they are collecting almost locations of all their millions of cabs. And these locations, they are collecting around 3 times in 10 seconds. Okay. Is my screen visible, guys? Yeah. Medha, please check it at your side. There's someone was having trouble. You can just check whether the screen, if you are watching from mobile, it might have gone to the backside or something like that, or you can log out and then rejoin it. Just check that. Okay, coming back. So what I was talking about is like a volume. So I was saying that the Uber was kind of getting the locations for their millions of cabs, and per cab they are trying to take 3 readings per 10 seconds. Now, longitude, latitude is not a huge amount of data, but when you have millions of cabs and you are collecting at the rate of 3 readings per 10 seconds, so though initially your data might be very small, so within few hours, you will be having a huge volume of data on your plate, correct? So this is something. The second one, we talk about the velocity. Velocity, the rate at which the data is generated, and that rate is probably going like a huge rate. That is something second. Nowadays, you talk about like a chat GPT and all that. So a lot of AI platforms are there, and the rate at which we are using these platforms, so rate at which the queries are going to these AI servers, it is a huge amount of data need to be handled by these AI servers. So Google searches, so like you've said that millions of searches are getting done probably per minute onto the Google. So you find that this high rate of the data will soon become a huge volume. So this is second characteristic. The third characteristic usually talk about is variety of the data. Now, traditionally, people were only talking about the data in a tabular fashion. So all RDBMS is talking about like a rows and columns and kind of stuff. So people were dealing the data like that. But then people started processing the data, which is kind of like a Facebook post. Now, Facebook post or like a Twitter post. Now, these are not a kind of a fixed formatted input data. Soon people started talking about the image processing, maybe audio processing, video processing. Now, such kind of data doesn't fall into the very much structured category. So we have kind of a unstructured data, which is typically a textual data or audio, video, images kind of data. So that sort of data, people start asking that how we can process. And trust me, guys, we are in 2025. We are still having limited processing of this unstructured data. Nowadays also, if you're using ChatGPT or something like that, you see that whatever images that we upload, so they are only still able to only collect the text from the play images. So still they are able to process only the OCR data. It is not that easy that you process whatever number of huge images that you get it, and that too at the very high rate. This is still a kind of a challenging. So we are talking about a variety of the data. Then the next point which came into picture, was like volume, velocity, variety is like all fantastic. That you can start calling the project as a big data project. But what if I have some terabytes of data, but the data quality is worst, or the data is not guaranteed to be good, or the data is having lot of null values, or data might be having some sort of a garbage which is like complete mess to handle. Now such kind of huge volume of data, but since you are not able to guarantee the quality of the data, if you cannot trust the source of the data, there was no point in like processing such kind of data. So this quality and trust level of the data was considered into another factor called as the veracity of the data. And finally, the people ask the most important question, that we have huge volume, velocity, variety, veracity, the data is good also, but then whatever processing that we will do with this data and all that, so does it bring some value to the table? Will it be giving me some good value, or is it going to add into the revenue of that company? What kind of projects that we will be making, and how our customers will be benefited? So this is something people start talking about. And this huge amount of data, if this is following these V characteristic, people started labeling it as kind of a big data projects. And these big data projects, why people were thinking differently? People were thinking differently because at that time, the mainly data handling system was relational databases. And the relational databases had certain common limitations. The very first limitation was kind of a how huge volume of data that you can store. The storage was the first limitation. Though people had RAID and all that kind of stuff, but still the storage in range of terabytes, petabyte, exabytes is not something which was really possible. The second thing, people were also talking about the handling, the performance issues. Because as your data started ranging in the terabytes or something like that, though your RDBMS accommodate that data somehow, when you execute some queries on that data, that was taking too much of time to handle that. That was, again, the performance level issues are there. Then how that performance issue to be solved? So people say that let us do one thing, let us just raise the configuration of the machine. Raising the configuration of the machine, which is technically people call it the vertical scalability. What is vertical scalability? If you had a machine of, let's say earlier 8 GB RAM, then you make a machine of a 32 GB RAM. If you have a machine with, let's say, 1 TB hard disk, you maybe make it like a 4 TB hard disk. So such kind of, you can increase the configuration. If your CPU is earlier 2-core CPU, you make it maybe 16-core CPU. And this way, you can increase a configuration of a machine. But the problem is that you cannot increase your configuration of the machine beyond a certain limit. So you cannot really think of, sir, I want one machine with 1000 CPU cores, or I want one machine with 1 terabyte of RAM, which is technically just not possible, correct? So there was a limitation on how much your single system can grow. And if at all you try to manage that, okay, I will have some good configuration machine, which is like, suiting to my requirement. But what will happen if something goes wrong with that machine? What will happen if that machine just goes down? Now, just starting that machine once again, till that your entire system is in like a halted state. So this a fault tolerance was another big problem with this kind of big data systems. And this is where the big data started talking about this particular processing cannot be and should not be limited on a single machine. So single computer is single machine or single computer is something that cannot be really thought of because of the several limitations that I just talked about. Then people started talking about, okay, let us move on to something called as a multiple computers, and let us start using these multiple computers for handling this huge data and their processing. So what is basically the distributed system? The distributed system, let me just give you an idea. You consider the distributed system is not your one single computer. By the way, when you talk about one computer, what your one computer is containing? My one computer is containing the CPU, of course, one or more cores that you talk about. You have RAM, that is memory, and you also have disk storage, the minimum required thing to make it as a computer, correct? And such, you have like a one computer, which I say that you will always have a limitation that how much this system can grow. So eventually, people started talking about, let us use multiple such things together. Instead of such one computer, let us connect multiple such computers in a network. Let us connect multiple such computers in a network. I'm very sure you people heard of a network, LAN, MAN, WAN kind of network, different topologies like ring topology, star topology, bus topology, whatever. So I'm saying that some sort of a network through which these systems will be combined together, will work together for solving your big data processing problem. So this particular system is called as this particular idea was called as a kind of a distributed systems. So distributed systems where multiple independent computers are going to work together over a network to solve one big problem, or this data handling problem, or probably for any other application. Such set of computers which are working together for solving a certain problem, this is known as a cluster. It is set of computers working together that is referred as a cluster, right? So you got the idea what exactly the distributed systems are. But in this distributed system, there are primarily two components of any distributed system they are worth talking about. So any distributed system, there are two primary things to always discuss. One thing you call it the distributed storage. And second thing that you always talk about is distributed computing. One, you talk about distributed storage, and second one, you talk about distributed computing. There are also additional issues like synchronization and all that, but then primary two most important things over here, one is storage, another is computing. So basically what this distributed storage talks about, the distributed storage, when I talk about, the basic idea of the distributed storage was, earlier, whatever file that you are storing on one particular computer, do you know that when you are storing a file on a computer, what exactly that file gets, how exactly the file gets stored? The file on a single computer, you will may not be knowing even, but just for your information, it is associated with some metadata and it is associated with some data. Now this metadata, people refer it as a information about the file, correct? And the data usually you talk about is the contents of the file. This talks about the metadata of the file, and this talks about the data which is talking about the contents of the file. So we have metadata and we have data. To keep it very simple, when you double click a file and file get opened in any kind of software, whatever you see in that file is basically a data. And when you right click on any file, you go into the property, whatever you see into the properties is nothing but the metadata. Just keep it that simple. But when we talk about a file on one particular machine, you realize that the data and metadata both are stored on the same machine, in the same hard disk, to be more specific, in the same partition. Partition means drive, C drive, D drive. So whole thing is kept at the single partition of the disk, correct? Just for your information, the data is divided into the blocks, into the small blocks, usually 4 kilobytes one block, when it is stored on a single machine. But as I say that, there will be limitation in storing huge amount of such file or the very big file. There will be a problem. This is not the only one problem. So many times people say that, sir, nowadays this should not be the problem, because nowadays we have RAID and it is very easy that we can have probably 8 TB to 32 terabytes of storage connected to the single machine. I agree with the RAID, and then with the advancement of the technology, you can always claim that you can store the terabytes of data on your single computer into your hard disk. However, though data is stored, terabytes of data is stored on one particular system, reading the data from the disk and processing that data in that particular computer's memory and CPU is not a possible job, especially when the data goes like too huge. So you just consider that even though you have 100 GB of data, just 100 GB of data stored in a hard disk, if you want to process that, you need to get that 100 GB of data into the RAM, and you will not be really having a RAM of 100 GB commonly at your home. That is not technically possible. I hope you agree my point. So though you say that you can have a huge storage, nowadays it is nearly impossible. It is not only about like dumping a data. Why we are storing a data? Because eventually we want to process that data. And that brought the idea that instead of storing the whole data on one computer, let us break it into the parts and store it on multiple computers. Means 100 GB of data, instead of storing on one computer, why don't you break it into the 10 computers, 10 GB each? If you keep it on 10 GB each on 10 computers, now each computer will be processing that data, only 10 GB of data, which is very much possible with available, what is that, RAM, with the available CPU. This is very much doable. Just making a huge machine, I say that it is not really budget friendly also, but having such multiple machines, you can do this kind of task parallelly. And that brought the idea of something called as a distributed storage. What is the basic idea of the distributed storage? The core principle of the distributed storage says that the data will be stored, data will be split into blocks. And these blocks are usually in size of megabytes. It is not a very small block of like a kilobytes or something like that. The size will be into the megabytes. And that megabytes of blocks will be stored across multiple computers in the network. They will be stored across multiple computers in the network, and then they will be loaded and they will be processed on those individual computers whenever they will be needed. But now people have definitely another question in their mind. Sir, what will happen if out of 10 computers on which you have stored data, if one particular computer goes down? Yes, this is going to be the problem always. And to handle that problem, this is going to be the challenge. So for any distributed system, though we say that distributed systems are great, they will be able to handle the petabytes of data and etc. That is true, but nothing comes for free. Everything has got its own problems and challenges. The biggest problem of any distributed system is that any one particular machine may go down. And if that machine goes down, the data processed and data stored on that particular computer is not available. So how exactly this particular problem is to be handled? As someone was saying earlier also, so I'm saying that there are certain characteristics the people were looking for when it comes to the distributed storage. The first characteristic, and that is like very commonly seen, that is nothing but replication. What is replication? The data is stored, as you already seen, the data is stored into the multiple blocks. The data is stored into the multiple blocks, but those blocks will not be kept only once on one computer. For each block, we will be having multiple copies stored on multiple computers. And what is the idea? If any one particular computer, say, let's say that one block is stored over here, that block, another copy is kept over here, so that by mistake, if this computer goes down, I should be able to access the copy from somewhere else. That was core idea of the replication. That was core idea of the replication. The second, of course, you talk about the scalability. So you want to store the more and more data. You just increase the more and more computers into the network. So instead of having 4 computers in the network, you can make 100, or you can make even 1,000 computers in a network. People have used more than 10,000 computer cluster. By the way, this cluster का जो एक node होता है, the each node in this cluster, in this one, it is called as a node. So I was saying that people have demonstrated using more than 10,000 nodes in a cluster, and this is to handle the huge amount of data. And if any particular machine goes down, the data should be handled by some other different location. That was the core idea about distributed storage. But I said that distributed storage doesn't come only for storing the data. The people were looking for this huge amount of data. We want to compute, we want to process in an efficient manner. Now you want to compute or you want to handle this particular data into the efficient manner. So how exactly it can be done? So this is where people come up with the concept called as the distributed computing. Now let me tell you, what is your traditional computing? In a traditional computing, people say that we write programs. Let's say you can write a program into the C, C++, Java, Python, Scala, any programming language that you want. And every program to run, yes, definitely it needs some data. Yes, definitely a program needs data. By the way, do you know that the data comes to the program from where? The data which is processed, to be processed by the program, from where exactly this data comes from? The data may be coming from the hard disk. Yes, that is true. So data might be coming from the different locations. The one source and the most common source is kind of a hard disk. That is true. The second possibility people talk about, people are using kind of database, the traditionally, and the data is coming from the database. That could be another one. The third possibility is that the data, they have kept it somewhere on internet, somewhere on a hosted server, maybe some FTP server or some HTTP server, from where people are getting the data, and people are doing the computing based on that. Now see the problem, guys. If you have a data into like a kilobytes, megabytes, that is absolutely fine. You can get the data from the disk, you can get the data from the database, or you can get the data from the internet. The real trouble starts when people start talking about, I want to process a data which is of 100 GB. Now think of it, 100 GB of data, though present in a hard disk, loading it into the RAM is not that straightforward, because this program is going to run on a single computer. When the program is running on a single computer, within a single computer with the RAM, with the hundreds of GB, is not really possible unless and until you are going on a cloud. Correct? The same thing, the data is stored in database, and you are saying that I want to get all that hundreds of GB of data onto my program, and then I'm going to process that. That is again technically not that easily possible. Or data same coming from the internet. I'm saying that the traditional flow, listen carefully, the traditional flow was that data kept at a source that is brought to your program execution, that brought where your program is getting executed. By the way, anyone knows the program in execution, what it is called as in operating system terms? The program is just a source code, but that program, when it is executed, what exactly it is termed as? The running program is absolutely correct. The running program is called as a process in operating system. So I'm saying that wherever your task, whenever your job, wherever your process is running, over there, the data is getting pulled. Now see the problem, guys. The data, जब तक MBs में है, you are pulling the data, no worries. But जब आपका data GBs में और TBs में चला जाता है, especially when you say that I'm not going to use now a single machine storage, I'm thinking that I will go for a distributed storage where my data itself is divided onto the multiple blocks into the cluster. Now the question is that how my program is going to process the terabytes of data. Now listen carefully. I'm telling you the central idea of the distributed storage. The central idea of the distributed processing. The central idea of the distributed processing says that ये जो आपका program है, the program data will not be pulled by the program, but the program will be copied on each machine where the data is present partially. The wherever data is present partially, over there, the program will be copied on machine 1, machine 2, machine 3. If your data is divided into the 1000 node cluster, your program will be copied on those 1000 node cluster, and over there will be a separate process created. There will be separate process created, separate process created, separate process created, and that particular process will only handle, that particular process will only process the data which is present on that computer. So please note, there is a drastic change in a way data is being processed. This is something that you need to visualize, and this is something that you need to understand, because whatever kind of distributed computing that you are learning, whatever kind of distributed computing that you are going to learn in future, the whole distributed computing has got a central idea that the data doesn't come to the program, rather program goes to the data. So वो हिंदी में कहावत है कि लाइक पैसा कुएं के पास जाता है, maybe कुआं पैसे के पास आता है. I'm saying that it is doing a kind of inversion over here. So the normal traditional data flow has been changed in a distributed computing. Your program in future, as the whole course is about the Spark में भी execution ऐसे ही होने वाला है. The program is not going to pull the data. The program is going to go to the part of a data, the blocks of the data which is available on multiple machines, and it is going to process the data over there partially, part by part, and ultimately all partial processing will be aggregated maybe on some other machine. That is the idea. So if I'm supposed to put it maybe diagrammatically, I would say that अब यहां पर हमारा फ्लो उल्टा होने वाला है. ये जो आपका प्रोग्राम है, your data itself is divided into the multiple machines. Let us consider that my data is kept. My data is kept on maybe machine 1. My data is kept, partial data is kept on machine 2. My data is kept on partially on machine 3. So I'm saying that my data itself is divided into the multiple machines. So we are talking about the program is going to be copied on that individual part of a data, and it is going to be processed. Are we trying to say about the partitioning? This is not exactly the partitioning. The partitioning is probably pretty advanced concept that we will discuss sometime later, where we will say that our data will be divided across multiple folders into the big data systems. But over here, I'm talking about some absolutely basic concept, though your data is present in a single file. Though you say that, sir, I have like one file, and that one file is, let's say, for example, of 1 GB. My file is of 1 GB. If 1 GB file is broken into the blocks of 100 MB approximately, if it is broken into the blocks of the 100 MB each, so 100 MB, 100 MB, 100 MB, 100 MB, अगर हम लोग ऐसे divide करते हैं, so what will happen? My 1 GB of the file is divided into around 10 blocks. And now these 10 blocks, Sujit, these 10 blocks may not be stored on a single machine. My 10 blocks will be again stored onto multiple nodes on the cluster. Though it is a single file that is broken into the blocks and stored onto the multiple nodes in the cluster. Now, whatever program that I'm processing, the program which is going to process that data, how the program can access that 1 GB of file. Here we say that the program is not going to fetch that 1 GB of file. Rather, the program which is usually in the range of KBs, I'm very sure जो कुछ भी big data में हम लोग program लिखते हैं, जो कुछ भी code लिखते हैं, that code never goes in a range of MBs or hundreds of MBs. Your code is usually into the KBs. So that KBs of code is very easy to copy on multiple machines and do processing of that data on those local machines. Usually, we follow a principle called a data locality principle. Data locality का principle का मतलब है डेटा जिस मशीन के ऊपर है, प्रोग्राम उस मशीन के ऊपर जाएगा और वहां पर जाके उस डेटा को प्रोसेस करेगा. Of course, I know that certain data cannot be processed only at the block level. At that time, to perform the further aggregate operations, जो कुछ भी result आएगा, that can be again copied onto some other machine, and that aggregations, the further aggregations can be done onto the separate machines. That is basically idea. Of course, there are like a lot of technical details are involved. So like somewhere that we are talking about shuffling and etc., all that kind of stuff. Someone is saying that how this code copy on different node to process data. That is the basically distributed computing frameworks are all about. So any distributed computing framework that you talk about, that all distributed computing framework, they do this internally, transparently. You are not even aware that what is getting done. You just write a program, you just run a program, but internally your program get copied. You need not to do it manually. And how it is internally getting done, that will keep changing from framework to framework. And we will discuss about the Spark framework in detail. Maybe probably more than one entire lecture, we have to discuss in detail that how exactly the data is getting processed onto the individual nodes partially. I hope that answers your question. Just to say the example of distributed storage could be HDFS, Hadoop distributed file system. That is one. The second thing we talked about, apart from HDFS, Amazon S3, it could be another one. Azure Blob could be another one, and so on and so forth. Yes, we'll talk about that. And then the next, the computing. When you talk about computing, distributed computing framework, you will find that the Spark is a distributed computing framework. Earlier, Hadoop MapReduce was a distributed computing framework. And then there are many are there. मैं अभी at this moment I'm not talking about Spark, I'm not talking about Hadoop. I'm saying that any damn distributed storage, any damn distributed computing, that any distributed systems, they will be following these central principles, the common principles. How in general? So in future you might be looking at, sir अभी कुछ market में कुछ नया एक और एक computing नया distributed computing का framework आया है. Trust me, with more or less difference, it is doing the same job. These foundations of this distributed storage and distributed computing started long back in the that Google's era, somewhere in like year 2001 2002. The Google started working on that particular stuff, and then later on these principles were like heavily used by the Hadoop based applications like Hive and all that, eventually then Spark, and then whatever new are coming up, they are not violating these basic principles. They are probably doing simplification of the coding standard. They are doing simplification of the access standard, but then they are not doing something out of the world. These basic principles remain same everywhere. Okay, there is something someone is asking that. So understanding, just a minute. Will program will process the data on data's machine? Correct. Since we are saying it won't bring data to the local machine. Exactly. That is what idea was. Sujit, you got it correctly. So program will go to the data, and then the data will be processed on that machine. Might be possible that whatever summarization is done, after summarization, if some small amount of data comes, so that might be fetched back. That is technically possible. There's something else, something that how does it validate that it has processed the complete data and not the partial data due to any uncertain challenges or so? Yes, challenges are always there. As I said that you are going to process the data onto the machines individually. So Snehal, your question is valid. Now see that a program is going from this machine to every node in the cluster. That is great. The program is running over here. It is creating an operating system process over there. It is going to handle the data over here. Something similar will happen over here as well. But there could be a possibility that something goes wrong with the machine and this machine goes down. This is absolutely possible. This sort of problem is always going to be there. And this is the main challenge that will be solved by the distributed computing framework. So it is a responsibility of the distributed computing framework to keep track of this partial data processing. And then if at all anything goes wrong with some part of a data processing, then that particular data has to get reprocessed, maybe on the same machine later, or if that machine is not reachable or the machine goes something wrong, then it will choose some another machine in the cluster, and that particular partial data will get reprocessed. That is a basically idea, and that has to be done by the distributed computing framework. Now there will be, of course, the master slave architecture and etc. that we will discuss for the Spark. How Spark internally does that, we will discuss that in detail. There is another question. Someone is asking that if data is stored on different nodes, the data is being replicated for those nodes. How to compute if node is processing the data on the same node and also same data on the second node? There we have processing time more, or process is also having any metadata. See, that is what I say, that this is the, now you people are, as whatever discussion that we had done, with that discussion, you people realize that how exactly distributed systems might be working. And with that, now people started coming up with the questions. Sir, ऐसा हो सकता है, कहीं पर data fail हो सकता है. Now someone has pointed out the question that what will happen if we have replication, and due to replication, one node is over here, same node is replicated over here. What will happen if the same process is actually same process, same program is processing the same data 2 times? Is it possible? Theoretically, it is possible, but this is what again the job of the distributed computing framework. So distributed computing framework, you will always have some analysis stage. Maybe at Spark, we call it as a driver, or Hadoop, we might call it as a MRAP master, whose job is to figure out exactly where my data is located, which copies, where they are available, and where exactly, on which machine exactly, which copy is to be processed. So that is entirely taken care while the job planning is done or the execution planning is done. I guess, Mehul, that answers your question. This is taken care by the job planning or the job execution process. What that? Okay. As I said that, as we will go ahead, so जिसकी जिसकी जहां जहां पर जरूरत होगी, स्पार्क में ये कैसे प्रॉब्लम सॉल्व किए जाते हैं, स्पार्क में एग्जैक्टली इस जॉब को एनालाइज कौन करता है, फिर वो जॉब को सबमिट कैसे करता है, एंड एक्सेट्रा काइंड ऑफ डिस्कशन वी विल सी विद द एग्जांपल, राइट? Yes, we have job tracker, task tracker earlier at the time of kind of a Hadoop. So they were doing the similar job. Absolutely correct, Mehul. So you got my point. So I was just talking about, guys, I was just talking about, in general, when I talk about any distributed computing system, any distributed storage system, how exactly they will look. Now, I guess I had enough of foundation, what is big data and what is distributed system. I believe I should jump onto the next point. Sorry. Something went wrong with this. Just a minute. Okay. Yes, we were discussing this. Fine. So what I was explaining you. So now you have got the idea. What is distributed computing? What is distributed storage? A very basic level idea. Now we should be in a position where we can talk about some concrete frameworks, or we can start talking about how this Apache Spark begin its journey. But it is like very much injustice if I directly start talking about the Apache Spark journey, because there were few key players who came into this distributed systems world probably well before Spark. And the first one in this plus series, and by the way, they also have very close relationship with the Spark journey ladder. That is the reason, let us spend again a very short discussion on some basic history. And the very first framework which was designed as a distributed system to process a huge amount of data which was available to public. And this is something important word I want to add, which is available to public, because there was definitely some system earlier developed by the Google people, but Google people kept it to themselves. Correct? So I'm talking about not what Google people has done internally. I'm going to talk about some system which was available to the developers, not only to the proprietary companies. And such system was Hadoop. Now, long back, there was like almost in year 2002, you will may not be knowing, but the person called as a duck cutting, and his colleague might be Mike. They were trying to work onto the search project, where you have probably the millions of pages, internet pages, web pages. You want to get the data from there, and you want to search that data into the data. So they were trying to improve the searching. And as I said that, year 2000 onwards, the people had the real challenges of handling the huge amount of data. So they were trying to work on a kind of a searching project. And for searching project, they have to make something called as a crawler, something referred as a nudge. So nudge was kind of first project that these were people were trying to make. And trust me, at the time of 2002, they were just using a single machine. And then they soon realized that with the single machine, nothing much we can do it significantly on that. Somewhere in year 2003 and 2004, the Google published some white papers. So one white paper in 2003, it was on Google file system, and second paper in 2004, which was MapReduce. One was talking about distributed storage, and second was talking about the distributed computing. And then duck cutting got the idea from these papers. Okay, this is something that can be done instead of using a single computer. If I use a kind of a multiple computers, I will be able to do it better. And then he started thinking of improving his nudge project. And that goes year 2005. In year 2005, these people have implemented that nudge project was ready, that was implemented, and it was a kind of a multi-node cluster, which was a kind of a distributed system, which was a distributed system. So that was developed. Things were going good. But of course, it was not too much ready for handling the real world data, and not a kind of a very foolproof kind of project. Of course, maybe due to the whatever resource limitations that this duck cutting has. Somewhere in year 2006, this duck cutting joined Yahoo company. And of course, Yahoo was still thinking of how we can process that huge amount of data. So at that time, the Google and Yahoo, they were like kind of strong competitor to each other. So they were also looking for how exactly we can solve this kind of searching problem. And of course, to search, you have to first collect the data, you have to store the data, you have to search from the data, means you need to process the data and all that kind of stuff. So somewhere in 2006, as at Yahoo, these people have kind of done a lot of modification into the nudge. And with that modifications in a nudge, what they come up with is something called as a Hadoop. That Hadoop was developed in year 2006. After it has been developed in year 2006, somewhere, just check the years, not very sure, some 1 year here or there. So you find that these people also made it kind of open source. Immediately after this has been developed, so it was made kind of a open source under Apache license, so that the world got access to these technologies, and they started working on these particular projects ahead. That was like a Hadoop. By the way, what these Hadoop people have developed, I said that the Hadoop people, they developed it something like a nudge project, and that was inspired from Google file system and kind of a MapReduce. So these people have developed both the things. A first one, they developed a storage layer. That storage layer, they call it as a Hadoop distributed file system. Second one, they developed something called as a computing layer, which is popular by the name Hadoop MapReduce. Then somewhere people realized that there were certain limitations and all that kind of stuff. So eventually the next version of the Hadoop that come up with something cluster management as a cluster manager, and that cluster manager was added called as a Yarn. By the way, that Yarn is even important at the time of Spark, because Yarn is a cluster management software, meaning by how many whatever machines that we have, so keeping a track of the machine resources, how many CPUs are available, how much RAM is available, and then based on that, how exactly different types of tasks are to be scheduled onto the different machines. इसके लिए जो core resource management of the cluster किया गया, that was the idea of something called as a Yarn, yet another resource negotiator. So बोलो sir, this Hadoop must have changed the world. Hadoop changed the world. Trust me, that change is still there. That is still going on. Everything is fantastic. But the only problem with this Hadoop was that whatever processing that you are doing, that processing need to be done programmatically. And unfortunately, that whole programming was Java based. Why it was Java based? Because the whole Hadoop itself was developed in Java. As whole Hadoop was developed in Java, the whole MapReduce programming, whole MapReduce processing is to be done into the Java. And you will not believe, but just to get the sum of some numbers, you need to literally write a code of 60-70 lines. कुछ numbers का sum करने के लिए आपको 60-70 lines का code लिखना पड़ रहा था. And this was not so easy. So you need a kind of a hardcore programmers. So though Hadoop was fantastic, though people consider the Hadoop as the people consider Hadoop to be used as a distributed computing, distributed processing, and all that kind of stuff, but it was not user friendly, you can say. It was not programmer friendly. So though you are a good programmer, still you are writing thousands of lines of code just to do some sort of a data processing. And this is where the lot of people found kind of Hadoop limitations. And then to overcome the limitation, listen to this Hadoop part, whatever I said, because इसमें से जो HDFS नाम का जो पार्ट है, ये वापस से हम लोगों को भी आगे जाके लगने वाला है. और आगे जाके मैं स्पार्क में आपको कुछ ना कुछ तो डेमो भी दिखाऊंगा, where we will be actually processing some data by getting that data from the HDFS, from the Hadoop distributed file system. Correct? So I was telling you that this MapReduce was having some problems. Problem number one. What is the problem number one? I said it was Java programming. So a lot of development time was like taking. And second, it was a bit slow. To be frank, even Hadoop was not designed for very high-end kind of machines. Hadoop was designed for commodity machines. Means a machine with 16 GB RAM or something like that with 3-4 core CPU. With that, Hadoop was fantastic to run. But of course, जो machine का capacity है, जो cluster का capacity है, उसके हिसाब से जो MapReduce job आप लोग execute कर रहे हो, it was taking significant amount of time, from minutes to hours, depending on amount of data that you are trying to process. Correct? Now this Hadoop was like adopted in early days by many companies. And then one such company was Facebook. Probably Facebook was started, I guess, somewhere early 2000 or 2002 or something like that, 2003 or whatever. At that time, initially, you might have heard of that. The Facebook was into the PHP and MySQL combination. It was such a simple and straightforward thing. But as Facebook was becoming kind of popular, the more and more data that these people start getting. Now, whatever data that they're getting, they want to process the data. They want to analyze that data. And after analyzing that data, they want to convert it into the business value. And then what was the limitation? Now, such huge amount of data processing in MySQL is not that easy job. So, sir, option batao. Option ye tha, these people thought of, we will look for some open source softwares or systems which can help us analyze our data faster. And the very early days, just in year 2006 or something like that, these people adopted. I'm talking about Facebook. So Facebook in 2006, these Facebook people adopted Hadoop. They started using Hadoop. And what is the primary purpose of the Hadoop? The primary purpose of the Hadoop was to perform data analysis. Now, whatever team members that they were having at that time, I was not very sure about the name, but then someone like Joydeep, one person was there, another one, and both of them were typically probably from the Indian roots. So these people have actually came across discussing how to write that MapReduce job and etc. etc. As I said that, छोटा सा data भी अगर आपको process करना है, तो भी आपको 100 lines of code लिखना पड़ता था. So these people like end up in writing thousands of lines of code just for doing the data analysis requirement, and that too execution like going very slow. The people were like thinking, okay, how we can do that, because then for that we need more and more kind of Java experts. While the Facebook company was driven mainly by the database oriented people, so almost all of them, they were expert of SQL, but their SQL knowledge was not getting used properly for the data analysis, and that was really challenging. So what these Facebook people thought of, listen this idea very carefully, because even that idea is getting used in Spark even today. Not only Spark, many other frameworks, they are working on the same idea which was brought by the Facebook in year 2006, 2007. So 2006, 2007, they said that we will be having certain tool, listen carefully, a certain tool which can convert our SQL, which can convert our SQL into Java MapReduce program, which can convert our Java that MapReduce jobs. So ये SQL to ये जो conversion है, this conversion process has to be done automated. So instead of writing the Java code again and again, और लेके एक ऐसा जावा का कोड लिखते हैं, लिसन केयरफुली, एक ऐसा जावा का कोड लिखते हैं जो जावा का कोड हमारे लिए जावा का मैप रिड्यूस क्रिएट करेंगे, करेक्ट? एंड दैट पर्टिकुलर टूल वाज नथिंग बट हाइव. That particular tool was nothing but Hive. So this is Hive. Of course, good news is that these people also 2007, 2008, these people also made it open source immediately. Open source immediately so that more and more development will continue on to this. Now, this SQL, listen carefully, this SQL processing के लिए, they didn't use plain SQL, but then they use certain dialect of SQL, certain variation of the SQL. The first thing that these people developed is something called as a HiveQL. Many times I call it as a cousin of SQL. HiveQL, Hive query language. Second thing, very important from the Spark perspective. The second thing that these people kept it something called as a metastore. The Hive का जो दूसरा central idea था, the second idea was that kind of a metastore. The metastore is nothing but handling the metadata of structured tables, structured data, structured tables. So आपका टेबल का metadata handle करने के लिए they had something called as a metastore. That is central concept that the Hive people brought in. And then of course, then there were like additional things were there, like optimization, that job execution engine, and etc. etc. So many additional things that they come up with. That is a different story. Execution engine, like a MapReduce execution engine, and etc. etc. That is not a big deal. But let me tell you, Hive के बाद में आज तक, listen carefully, Hive के बाद में आज तक जितने सारे big data के popular tools बने, who are using SQL for processing a huge amount of data, they are still following the same concept. They are still following the same metastore that was developed by the Hive people. So something that was developed in year 2006, 2007, the same metastore, even today, it is getting used by other systems like Impala, even for that sake Spark. आगे जाके जब हम लोग Spark में concept आएगा, Spark में we will talk about the metastore and etc. etc. Nowadays Spark में instead of metastore, they start using a word called as catalog. But then ultimately that catalog and everything is basically the abstraction level or a wrapper on the Hive metastore concept itself. That's why I can never ignore the contribution of the Hadoop and Hive. Correct? Because thereafter, the next one, something that you are really interested in, is about Spark. Something you are really interested into the Spark. Now, this Spark is somewhere started in year, let's say 2009, you can say. The development began in year 2009. The public release is available 2011 or something like that. But 2009, somewhere, who was doing that? University of California, Berkeley. University of California, Berkeley. Now, this University of California, Berkeley, they were having one department called as a AMP Labs department. AMP Labs, AMP stands for Algorithm, Machines, People. Algorithm, Machines, People, that particular department, they were trying to work on some machine learning projects. And now, you may be aware, maybe known a little bit, most of your machine learning projects, this data processing is kind of an iterative process. Iterative data processing. Now that iterative data processing means what? Whatever records that you have, whatever amount of data that you have, you are walking through that data in a multiple passes in order to improve the processing. That was the idea about the Spark. So I was saying that the machine learning is nothing but मशीन लर्निंग के लिए जो इटरेटिव प्रोसेसिंग करना पड़ता था, इसके ऊपर ये लोग काम कर रहे थे. What they were using? Of course, they were also using the same thing called the Hadoop. ये लोग भी underline, they were still using Hadoop for data processing and maybe MapReduce computing process. And then what was the challenge? The challenge was that Hadoop MapReduce is really bad for such kind of iterative processing, because if your data is huge, going in a terabytes, you want to train your data, train your machine learning model on the terabytes of data. At that time, there were serious limitation. The speed was not at all good. So this is where that team, that AMP Labs, which is headed by Matai Zaharia, so the team, they start thinking of क्या हम लोग कोई दूसरा अच्छा distributed computing framework बना सकते हैं. Please note, what they were trying to make, what they were not trying to make replacement of Hadoop, but they were saying that they were basically facing limitation with the Hadoop MapReduce. Since they were facing limitation with the MapReduce, they thought of, we will try to develop some distributed computing framework which can work with any storage, and this distributed computing framework, these people name it as Spark. So you ask the question, so what great that these people have done? What great that these people have done? The basic limitation of the Hadoop was the data processing at the hard disk level and the RAM level. So the biggest change that these people try to do is that they start doing a data processing in RAM. So processing in RAM, there are many other differences are there, but the biggest difference was processing in RAM. And with that processing in RAM, does it anyway improve the performance? It improved the performance by 10 times to 100 times. Your performance was increased from 10 times to 100 times. Such a huge performance boost that they got. Please note that Spark का जो जन्म हुआ था, ये basically machine learning type of applications develop करने के लिए ही हुआ था. Correct? So that is something the Spark come up with. So those people come up with the centralized idea. There is a core idea which we will discuss maybe sometime later in detail, not today. RDD. RDD stands for Resilient Distributed Dataset. That was in-memory processing. That was a core idea that like Spark people come up with. That was a core idea that Spark people come up with. And with this, what they achieved the speed of execution. That was the first criteria. Second thing, I said that MapReduce program जो आप लोग लिख रहे थे, the MapReduce program was written in Java. And the problem was that simple addition वगैरह भी करना है, तो you have to still write 50 to 80 lines of code. What these people say that if you want to do kind of simple operations, you can do it hardly in like a 5 to 10 lines of code. You can process even a huge amount of data. That was something, the biggest breakthrough. So जो पहले MapReduce का जो प्रॉब्लम था कि बड़े बड़े कोड लिखो, और आपको पता है आप सॉफ्टवेयर डेवलपर्स हो तो जितना बड़ा कोड उतने ज्यादा एरर्स. तो Spark has reduced that code to probably even 10 times reduction in a code, you can say like that. So within few lines, you are able to process the same sort of a data. Third one, they said that we will not limit, listen carefully, we will not limit our whole data processing to one particular language. We will provide you multiple different options. And they provide the options like you can do the programming in Scala. By the way, Scala is a language in which Spark was developed, correct? Which is a JVM based language. So Scala was allowed. Java was allowed because it is JVM based language. R was allowed. The R was like very popular language by the data scientists at that time. So R was allowed. And Python was growing rapidly at that particular time. So the Python was allowed. So these 4 languages, and eventually soon within 1-2 years, they said that why not directly do the processing using SQL language also. So they also added support for SQL. But by keeping all these kind of things in a different language processing and etc., what all that they tried is nothing but they keep the same APIs. They keep the same APIs. So they kept the same APIs, and with that same APIs, with the similar performance, they were able to handle it. That is good. And then this plus Spark, they were not keeping it limited to Hadoop. Though, yes, of course, they begin with the Hadoop as a processing, but they didn't limit themselves for the Hadoop. They also say that we will be able to process your data with your AWS storage or some other cloud storage or any other distributed storage that is available. We will go with this. Please note, Spark was designed to be distributed computing engine, not the storage. So of course, in this course, we will not be discussing too much onto the storage side. We will be discussing too much onto the computing side. We will discuss too much onto the computing side. Now that you have got that, the big platform, that what exactly to be done and etc. kind of stuff, then you have maybe the next question. What exactly Spark has to offer? What exactly Spark has to offer? We will just quickly talk about that, and then we will get started with the basic setup and maybe kind of a hello world application for today. Correct? So what exactly Spark has to offer? What exactly Spark has to offer? Something I call it as Spark Toolkit. What is that? Spark Toolkit. And this Spark Toolkit, what all components of the Spark are present. The first one, I would say that it is a low level APIs. Spark provide low level APIs, and these low level APIs are nothing but the core of the Spark, called as a resilient distributed data set, IDDs. And second thing, it is talking about DAG, directed acyclic graph, which is basically the execution plan. So IDDs represent the data, and directed acyclic graph, which is representing the execution plan. This is a foundation of the Spark. So the first year 2009 version, that was basically this much. But then soon, I said that this programming style was not that easy. Not that easy in the sense, you need to then, what I can say, you need to write a lot of functional programming kind of approach. So functional programming kind of approach, though of course it was still far better than the Java's MapReduce. It was far better than Java's MapReduce, but not that intuitive. So people were saying that everyone who want to do the data processing, RDBMS and SQL language was almost everyone knows. So these people were saying that why can't we develop something on the top of our basic engine where we can facilitate people by using the SQL language, correct? And this is where they come up with something called as a high level APIs, which are also referred as a structured APIs. It is high level APIs, or these high level APIs are also called as something called as a structured APIs. And these structured APIs, there are 2-3 most important things into this. The first thing that they come up with something called a data frames. The first component that they come up with the data frames. Data frames is something which represents data in memory like a table, like a RDBMS table. Table means rows and columns I'm talking about. So it's like a data frames. The second thing that they come up with is something called as the data sets. Data sets are more of typed object, more or less typed object, which is bringing type safety to the table. Data sets are kind of a wrappers you can consider for the data frames, which are for the type data, but the data sets were limited to the Scala language. Data sets were not available for the Python kind of languages. They are not even available now. And that is the reason the data set was kind of a limited use. Though data set is there, but data set people, only few companies or few projects which are developed in Scala, they are using data set. If someone is looking for the Databricks exams or something like that, उसमें भी data set के ऊपर ज्यादा कुछ नहीं पूछा जाता है. And वैसे भी Python doesn't have a support for data set. So we are not anyway planning that, okay, we will learning data set. But the third thing, the data frame and data set, these are still a program. And then people were saying that, sir, what if I can write SQL queries directly? The way people were writing a SQL query in Hive. Hive may you write a SQL query and automatically internally the job execution plan was getting created. So does it mean that we should start using Hive with the Spark? वैसे to be frank, बीच में लोगों ने ये भी कोशिश किया था, लेकिन Spark people later on say that why are you using Hive only for like writing SQL query? Let us provide the SQL query support directly into the Spark itself. Okay, that is wonderful. Now Spark, all your high-level APIs, they are based on data frames, data sets, and directly the SQL queries that you can write it. That's it. Is it all about Spark Toolkit? No, I didn't say like that. There is something. Then people started asking about, what if we want to do the live data processing? We want to handle the real-time data, the data which is getting generated from certain IoT sensors or something like that, and I want to handle live, or like people are doing tweets on the Twitter or something like that, and we want to immediately do kind of a sentiment analysis on that data immediately. So what is to be done? What is to be done? This is where we talk about the Spark structured streaming. There was an idea called as a structured streaming. The streaming is all about processing live data or real-time data processing that is done into the structured streaming. That was good. Then Spark was originally designed for what? Machine learning projects. So yes, it was designed for the machine learning project, or the research was going on to that, how we can train the models on using distributed computing. This is where these people then continued with their machine learning library, MLlib, or you can call it as a structured ML, whatever. These are the machine learning library. People were also talking about a kind of additional analysis. People were also kind of talking about the additional analysis. So people looking for some extra libraries and etc kind of stuff. So Spark also come up with the additional libraries and ecosystem, additional packages. There is one website, sparkpackages.org, where a community supported libraries are available on the top of Spark. This is everything is a part of a Spark toolkit. That is good. And which languages are supported? I told you the language support. So the first language that was supported is nothing but Scala, in which it was developed. So you can write Scala applications, you can write Java applications, you can write R applications, you can write Python applications, and also SQL is a primary language that is supported. So the developer got the freedom, आपको जिसमें डेवलप करना है उसमें डेवलप करो, and the guarantee was given that आप किसी भी लैंग्वेज में प्रोग्रामिंग करो, your code will be similar in, the actual code, मतलब API names and all that, they were kept similar, and also the performance will be similar. That was a fantastic job done by the Spark toolkit. Now you ask the question, तो सर Spark अगर हमको पढ़ना है आज के जमाने में, तो आज के जमाने में हमको Spark में क्या फोकस करना चाहिए? आपके आज के जमाने में अगर आपको Spark पढ़ना है तो something I believe that you should master is data frame programming. Number one, you need to be excellent with data frame programming, because इसके ऊपर जो आपका structure streaming है, या machine learning libraries है, या फिर Spark libraries packages है, ये सब कुछ everything is basically based on data frame only. So if you skip data frames or you take data frame programming lightly, there will be always problem with whatever else that you try to learn on the top of it. That is one. And the second one that people are preferring day by day is like SQL. So in my opinion, these two are like most important concept. Now the next question. So what are programming languages? Which programming language that I should be choosing? If you ask me personally, I learned Spark probably a few years back, like 2017, 2018 at that time. And 2017, 2018, whatever that programming that I was talking about, at that time, I learned Scala for learning Spark. I don't know, but then somehow I believed at that time that, okay, doing Scala programming will be like kind of more efficient. But then eventually the Spark people themselves publish that we are having now such kind of optimizers where you need not to spend your time into like language specific stuff. You just choose any language and we will generate exactly same plan. And there onwards, you find that even the world moving now, rapidly towards something called as a language called as Python. In fact, our whole course is talking about PySpark. What is basically PySpark is? What is basically PySpark is? Something that we are going to learn in that entire course. That is the name of our course. So what is basically the PySpark? The PySpark is basically, you talk about, it is a Spark programming in Python language. It is such a simple thing. It is Spark programming in a Python language, number one. Number two thing that you talk about is Spark programming in Python language is number one thing. Number two thing that you talk about is PySpark is also a Python package. It is also a Python package. It is also one of the Python library that is provided. And this Python package, which is available onto the PyP, which you can simply do pip install on Windows or Linux or Mac, and you can start using PySpark in your computer. Is that okay? This was overview of what is Spark Toolkit. Have you got a bit idea what exactly the Spark is all about, and etc, etc? And as I said that our course will be primarily focusing onto this in depth. We'll be learning this. We will be covering almost all the things from there. We will have introduction to the machine learning. We will talk about the low level APIs also in detail, because architecture अगर आपको पढ़ना है तो architecture के लिए आपको RDD और DAG समझ में आना ही पड़ेगा, कोई choice नहीं है. We will be talking about that as well. We will be sticking to the Python and then the SQL language. This is something our course is going to be all about. I hope you got that point. Is that clear? I was just talking about what exactly the Spark is all about. Guys, may I have some quick feedback? So far, is it okay? That quick introduction? It's clear? That's great. Now, if that is what a big picture is, we are saying that we want to start with the PySpark. So you ask the question, how do I install PySpark? How do I install PySpark? And how do I start programming in PySpark? Now, luckily, if you are onto the Linux, actually मैं जो पोल लिया था, पोल के अंदर मुझको एक्चुअली एक क्वेश्चन और पूछना चाहिए था, on which machines that you are working. So which platform that you are right now using for the development. ये कोर्स में जो कुछ भी प्रैक्टिकल चलने वाला है, उसके लिए आप लोग क्या यूज करने की कोशिश कर रहे हो? May I have some quick feedback into the chat? What exactly? No, I'm asking about the operating system that you are going to use. You are planning to use. Wow. So, chalo, I have got maybe at least 10 answers, and all 10 answers people are talking about they will be using Windows. Let me tell you that the Spark was never designed for Windows. And not only Spark, almost all big data systems, they are not designed for Windows, because Windows is not the server class system. Windows is not where your applications will deploy, correct? So your all big data applications, they will be deploying onto the Linux, technically speaking. So almost trust me, जितने सारे distributed systems मैंने देखे, जितने सारे big data framework मैंने देखे, they were all Linux ready. And that is the reason, अगर आपको Spark installation करना है on Linux, then it is one of the very easy job. One of the very easy job. Let us assume that all of you are going to use Ubuntu. I'm just saying that अगर आपको Ubuntu के ऊपर डेवलपमेंट करना है, तो how simple Ubuntu development would be. Just a minute. Give a minute. I'll just start a machine by the time. So what I was saying is that the Ubuntu, I was talking about Ubuntu, and this Ubuntu installation of the PySpark, at least the developer machine installation is very, very simple. All you need is one command. What is the command? You have to just say pip install PySpark. That's it. You write this much and your machine is ready. Of course, it is not that straightforward. उससे पहले you need to still install few more things. Maybe apt install. You might need to install OpenJDK. You need to install OpenJDK. You need to install Python. That is for sure. So you need to install Python. Maybe Python 3. You need to install OpenJDK. That is for Java. Because Spark is written in Scala that works in a JVM. So you have to have the JVM ready for the system. Correct? नहीं 2 मिनट रुको मेहुल. I'm just telling you. OpenJDK 17 JDK. You can install. क्योंकि जो latest Spark का release है, that works well with the Java JDK 17 and JDK 21. That is good enough that you can do. लेकिन I was knowing that somehow people love Windows and like it is accessible to everyone. So I thought that though it is not like fully, but many of the programs of this blog course, I will tell you the setup, how we can do that setup on Windows. Correct? You can also run Spark natively on Windows. The only problem starts when you want to use Spark with Hadoop, because using Hadoop on Windows is really a nightmare. Spark on Windows works with छोटे मोटे कीड़े करने पड़ते हैं, but then it can work. So अभी जो मैं आज आपको जो सेटअप दिखाने वाला हूँ, so मेरा प्लान तो यही है कि I want to show you a setup on Windows. What is that? I want to show you setup of this itself, Windows itself. So how to install it on Windows? मैं यही सेटअप दिखाने की कोशिश कर रहा हूँ. Let's see. Give a minute. Let me check if my machine can go in a full screen mode. Yes, it is in full screen mode. And then you ask the question कि क्या-क्या installation करना पड़ेगा. So just take it like this. क्या-क्या installation करना पड़ेगा. I will share the detailed what is that, guide of installation onto the GitHub repository. The link of GitHub repository will be shared on your WhatsApp group. Correct? So ये पूरा मैंने document करके रखा हुआ है. The documented thing I will also share with you. If you just want it, I can just quickly show you over here. I said that all the things that you need, actually I have made it available into the drive for the installation. And then whatever installations that you need to do, I have already written a quick documentation for you. So don't worry about it. So I had that documentation ready and I will share that documentation with you. The very first thing that you need to install is Java, where your installation will begin. I'm showing you the Windows installation because Linux installation is pretty simple, pretty straightforward. I wish that you will be doing this kind of installation, maybe today, tomorrow, whatever. And on Monday, people who are kind of facing problem with the installation or something like that, feel free to join, 15-20 minutes early. I will be there into the meeting and we will sort out the errors, if any. Correct? So I'm setting a Java home. Please make a note of this. Java home variable आपको set करना है. Path variable में Java को add करना है. That is required. And I just click on install. And that is my first thing. My Java is installed. And it is recommended to install OpenJDK instead of going with like a Oracle specific JDK. So JDK is installed. Congratulations, the first part is done. The second part you need to install is a Python, the Python 3. And yes, Python has got many different versions, but I would say that Python 3.10 is a kind of a stable वर्जन, जिसके ऊपर आगे के कुछ अगर आपको लाइब्रेरीज यूज करने हैं जो स्पार्क के साथ में और किसी चीजों के लिए भी अगर आपको यूज करना है, मे बी जनरेटिव एआई और उससे रिलेटेड भी अगर कुछ करना है, तो पाइथन 3.10 इज लाइक मोर स्टेबल. दो पाइथन 3.13 इज द लेटेस्ट वन. स्पार्क प्रोग्रामिंग में प्रॉब्लम नहीं आएगा, लेकिन जो बचे हुए लाइब्रेरीज आप उसके साथ जब इंटीग्रेट करने की कोशिश करते हो, उसमें यूजुअली द लेटेस्ट पाइथन हैज गॉट लिमिटेशन. Do not forget to add Python into the path variable, and you can click on install now. You can click on install now. So we are installing the Python over here. I have Python. Should I reinstall? As I said, अगर आपको सिर्फ Spark प्रोग्रामिंग करना है तो Python 3.13 is also not a problem. लेकिन उसके साथ में अगर आपको मे बी टेंसरफ्लो या अगर आप ऐसा आगे जाके कुछ और लाइब्रेरीज के साथ डील करने वाले हो, at that time 3.13 is not a great choice. Only for Spark, आप Spark छोड़ के और कुछ नहीं करने वाले हो Python के साथ, then it's okay. 3.13 should be fine. That's why I usually restrict myself to the lower version, not the latest one. When I teach only Python, at that time I usually teach the latest version. Correct? There is one more thing to check over here. Disable the path length limit so that it can also handle the bigger paths on your system. We can use PyCharm over VS Code. Yes, you can use PyCharm over VS Code as well. I was preferring PyCharm earlier, but then nowadays I find that VS Code is like more lightweight solution. So usually I go with that. But anyway, you can install PyCharm also. Absolutely no problem, whichever way. For this course also you can use. I'm going to use VS Code. On my machine, I have not installed PyCharm. The earlier courses that I usually teach, जहां पर already PyCharm install होता है, मैं वहां पर वो करता हूँ. If you want, I can show you one demo of using PyCharm also. Not a problem. Okay. Chalo, this is the second thing that we have installed. VS Code, if you want it, yes, you can get it installed immediately. For time being, let it be over here. Now, something very important. अगर Windows के ऊपर आपको काम करना है, you need something called as a Hadoop utilities. You need something called as a Hadoop utilities. This is an extra step that Windows user need to do. So what I'll do is that I'll create a folder, Spark. You can give any name to the folder. In that folder, I can somewhere maybe paste this, that is okay. And then we can extract. Over here. Done. Chalo, Hadoop is ready. Now this one, I need to set it into the path variable. So I'll just go back and I will handle the environment variables. Please take a look at this. I'm going to the environment variables, system properties. Into the environment variable, let me create a new environment variable called as a Hadoop underscore home. And whatever Hadoop that we have extracted right now, it is not Hadoop. It is just some libraries of Hadoop, WinUtils library, Windows utility libraries. So that I have given over here. That is C:\Spark Hadoop. And another one, I need to modify the path variable. Into the path variable, I will do the changes. Let's say whatever Hadoop home that I have set up over there, this /bin. This /bin. So that bin folder we are adding. Basically, what that bin folder contains, it contains certain libraries. You know, they're like a HDFS related libraries, something like a Hadoop related libraries. So this is a very small one, but that is something you will need it. That is taken care. So your Hadoop home is set, it is done. Now, another problem that you will be actually seeing if I run your system. Let me just show you. Let me run it and let me show you. अब आपको क्या इंस्टॉल करना है? Of course, now I need to install PySpark. So to install PySpark, you will have pip install PySpark. Now this is probably a bit bigger download, and maybe you see that the latest PySpark version that is going on is 4.0.0. Okay, well, so it is around 400 MBs of download, and that download we need to do it. This is PySpark is a Python package that is primarily designed for development. Please note that इसको यूज करके आप लोग स्पार्क का क्लस्टर नहीं बना पाओगे. How to create a Spark cluster of a single node cluster or multi-node cluster, that we will learn separately. And for doing the Spark cluster development, the Spark cluster formation, we will be downloading it from the Apache's website. Okay, we will talk about that separately. This is completely the development machine setup right now. So we are learning Spark 3 or Spark 4. To be frank, the most of the feature that I'm teaching is actually Spark 3 features, because almost all these features are coming from Spark 3 only. Spark 4, in my opinion, it is not like two major changes are there, correct? But we are going to do the programming in Spark 4 only, and nothing from Spark 3 is actually removed into Spark 4, so that should not be the problem, right, Manoj? Even though you install Spark 3.5 or some version, that is absolutely okay. No worries on that. Majority of features that we will be learning in this blog course, they will be focusing onto the Spark 3.5 only. Currently, the latest version is available, which is PySpark 4.0. So I thought that I'll better have that, so that installation steps remain simple, right? Now you see that my PySpark is installed. Now see the problem. Now guys, see the problem. You consider that, okay, then can I start using PySpark immediately? Let us just try it. Let us just try it and see that it is somehow raising some sort of errors. You see the error? Check that Python is not found. So sir, हमने Python install नहीं किया क्या? You will see that the Python is somehow installed. A Python is installed. आपके सामने install किया था 3.10.8, but somehow it is not taken automatically. So what is to be done? Now for this, you need to set some extra environment variable. You need to again go back to the environment variables. Do not forget to close that terminal. And I need to set the extra environment variable. By the way, do you know where your Python is? आपका जो Python install हुआ है, आपका Python exactly कहाँ पर install हुआ है? Are you aware of it? If you are not aware of it, first go and find out where your Python is installed. So you will find that जो Python अभी मैंने install किया है, that python.exe, that got installed at this location. That got installed at this location. So I need to tell it that I will create a new environment variable called as a PySpark के लिए कौन सा Python version use करना है? A PySpark के लिए Python version जो use करना है, which is this Python 3.10, and you will find that python.exe. A python.exe from that location. This is the first thing that I set up, which is PySpark_Python. And then there is one more. PySpark_driver_Python. It is yet another variable that I need to set up with the same path. Please do not do any sort of spelling mistakes. Otherwise, it is going to be the tough job. Correct? So you can set up this. I can click on OK. And things are ready. Please note, मैंने वो terminal close किया था. Now, I will open that terminal once again. And in that terminal, now I can give a try on this PySpark. Let me just check. Is PySpark is getting open now? Let's see if it is working. Chalo, someone is asking the question. Already install किया हुआ ISO file. The directly ISO file, many times I have seen that it doesn't work very well. I had given it to the people, but then I personally do not recommend that you put it in a virtual machine, because if you put it in a virtual machine, then your RAM will be kind of limited. But most of the people, they have लैपटॉप विद 8 GB रैम और 16 GB रैम, उसमें से वर्चुअल मशीन को जो रैम आप लोग देते हो, सो दैट रिमेन्स लाइक हार्डली 8 GB और सम व्हाट दैट 4 GB. With the 4 GB of RAM, there will be a lot of limitation. If you have 32 GB, that is good. So for me also it is 32 GB, so it is going good. Hey, by the way, the PySpark is ready. The PySpark is ready. PySpark is loaded. Now PySpark is loaded. एक काम करते हैं, एक hello world program लिखते हैं without understanding anything, just to check whether our system is going good or not. I'm telling you that I'm not explaining anything, but what I'm saying is that let us write a particular small program just to check whether the things are going correct or not. You will see that by default, a Spark session is created as a Spark. A Spark session is created as a Spark. We can use Spark session to load some data and use that data. Let me just check that whether I have some data available. I have some data available called the novels.csv file. Okay. This novels.csv file, you can check that it is like a very small data. Just to check, oh yes, this is a novels.csv file, and this novels.csv file having some serial number, having some title, having author, having some category, and having some price. This is such a simple data that is available, and this particular data I want to now process. So let us collect. By the way, this is a complete Python shell. Complete Python shell means जो कुछ भी आप लोग पाइथन के कोड लिखना चाहते हो वो आप लोग यहाँ पर लिख सकते हो, and all Python syntaxes are absolutely valid on PySpark shell. More about details, what is happening and how the development setup is done and etc kind of stuff, we will of course continue on to the next class. लेकिन basic installation I just want to show you right now. Let's see. A file path is equal to, let me choose a file from C colon, and the file path C colon for me, it was, let me just check the path of the file properties. A path of the file is this. Now Windows has got its own issues, especially with respect to the slashes. I usually prefer going with the Linux slash. I prefer going with the Linux slash. File का नाम था novels.csv. Then this is a file. Can we load that file? Let us check how we can load the file. I will explain this whole code in detail, line by line and word by word into the next class. Today we are just checking it. So we have Spark session dot read to read the file. Let me tell it some option. Like for example, I'm giving option header is equal to true. Good. The another one that we are looking for is like a infer schema. Infer schema is also equal to true. I'm telling it that you automatically figure it out that how many columns are there and etc. Header is equal to true, so it will take the column names from the header, and then you are going to read the CSV file whose file path is given. Done. Oh, sorry, my bad. One option I have given. I need to give another option, infer schema. Done. Great. Now the question is that, has it got any schema? Let me check that as well. So data dot that data. This data is basically the data frame. This is basically the data frame, what we were talking about, the Spark high level API. Correct. So let us check whether it has got any schema. Oh, this schema is there, which is telling me that price is integer, title is string, author is string. Oh, that is wonderful. And now can we perform some operation on the data? Yes, we can perform some operation on that data. अब जिनको SQL आता है, I'm very sure those people can appreciate it better. So result is equal to somewhere I can say this data dot the kind of operation that I want to do on this data is grouped by maybe category, and I want to do the sum of price. Right? I'm writing this much and I'm just saying enter. So where is the result? Where is the result? Let me show you the result. So result dot show, and it will take a little time, and you see that in a different category. So mythological novels total is 980, biography novels total is 380, historical novels it is more than 2000, and humor novels it is like a 350. अगर आपके मशीन में इतना कोड रन हो रहा है, so there are likely chances are that your system is doing good. By the way, if you want, you can also save that result in some particular folder. How you can save it in a particular folder? Let me also write that as well, which will ensure that आपका Hadoop environment variable and everything is also set correctly. So take a look at this. What I was saying is that result dot write, and I want to save it into the CSV format. I want to save it into the CSV format. Let me provide some path. Let me provide some path. Please note, this should be the path of a directory. This should be the path of a directory that doesn't exist. This should be the path of a directory that doesn't exist, so that whatever is this particular result will be ultimately stored in that particular file. अगर आपका Hadoop का इंस्टॉलेशन अगर ठीक ठाक हो गया है, अगर आपका Hadoop का इंस्टॉलेशन ठीक ठाक हो गया है, then this line will not give you any error. Hadoop का मतलब I'm talking about Hadoop WinUtils, correct? अगर आपका WinUtils अगर कुछ भी गड़बड़ कर रहा है, तो स्पेसिफिकली ऊपर के कोड वैसे भी चल जाते हैं, but this code usually fails, right? Let us just check. मेरे को कोई एरर नहीं दिया है. So you see that summary नाम का एक फोल्डर यहाँ पर क्रिएट हो गया, and that summary folder you'll find that there is a CSV file. The other files you need not to worry about, but there is a CSV file which I can open it into the notepad. And do you see the result over there? जो वहां पर 2 columns थे, exactly 2 columns, and that same result is available over here. I hope this is done. Correct? I'm just saying that this is how you can test whether your whole setup is working correctly or not. Is that okay? If this is going well, and if it is producing this spindle output, I believe that you are ready for the next class. In the next class, we will start focusing onto the data frame programming. And usse pehle, I would strongly recommend that better you join 15-20 minutes early next session, especially those people who are facing any errors in installations, correct? So that we can sort out your errors, we can solve your errors, and then sharp 7 o'clock, we will begin with the explanation of this code, and then there are a few more conceptual things to be discussed, right? Yes, can you share the Git link? Yes, Git link, I will share it on a WhatsApp group actually, but let me just show you quickly. It is available somewhere on github.com, maybe Sunbeam modular / Spark-O-04. This is where I will upload all this data. I will upload all this data. You can just check. I'm sharing that link over here also. So I'm just going ahead, and I'm very sure that you people have taken a look at our syllabus, something that I had designed keeping in mind what currently the industry is using, how exactly the companies looking forward to go for the Spark programming, and actual real life applications, how they are working on, correct? So we are starting today, and this particular course, as you focus, we are going to begin with some ideas regarding PySpark. Basically, PySpark is nothing but the Spark programming using Python. So we will even start today about what is Spark, what is big data, what is fundamentals, and then the whole programming of Spark we will be planning using the Python language, because nowadays the PySpark is most used dialect of a Spark, we can say. And as of now, if you ask me in industry how that Apache Spark is getting used at maximum level, how it is getting used at the maximum level, so you will realize that it is more of onto the data frame programming and kind of a SQL programming. So these foundations of data frame and SQL, we will try to cover in depth as far as this plus Spark course is concerned. We will be able to use all these core features of the Spark for the real practical use cases. Correct? Then, of course, we need to also learn how this Spark works behind the scene. So to understand how Spark works behind the scene, we need to then get into the depth of the Spark architecture. We need to understand the internals. And then these internals are mainly focused onto something called as RDDs, resilient distributed datasets. So we'll talk about that. We will also see what all internal updates are brought by the newer versions of Spark. We will also talk about certain advanced topics, kind of a Spark performance tuning and so on, right? Apart from this, as we are talking about the Spark implementations and the modern implementations, they are more going into the somewhere like a data lake concept. So earlier, most of the Spark development, we were like more focused onto the data format called as a Parquet format. But now it is like more going towards a kind of a delta lake format is becoming popular day by day because of primarily its ability to perform insert, update, delete operations, which were like limited, not possible into the earlier data formats. So we'll talk about that. And this actually talks about all batch processing side. The batch processing side, where we will be using all these kind of concepts. We'll be also talking about the optimization. We will be also talking about the best practices. We will also talk about the implementations over there. But then people are also interested in knowing, can we use Spark for the processing live data? And that live data processing is typically referred as a structure streaming. The structure streaming is all about getting the live data and processing that live data. And for processing that, something which is like most popular data source that, yes, I had like many requests where people were talking about, which are covering Kafka as well. So I thought of, yes, we will be getting into the Kafka. We will be discussing the Apache Kafka probably in details. So understanding architectural side, and then how the Kafka will be used with the Spark. Of course, the focus of this course will not be like Kafka and microservices as such, but yes, understanding Kafka very well, the core of the Kafka, we will spend probably one entire session or probably more than that into understanding Kafka internals and Kafka architectures, Kafka's terminologies, running Kafka individually, and then somewhere we will get into the Spark and Kafka integration as well. So we'll talk about that. Then that comes like a Spark machine learning. I just want to make it very clear that this particular course is not really planned for teaching machine learning concepts. But again, many people who are getting started with the Spark, and many of them nowadays know machine learning probably in advance. So I just thought of having one session related to the Spark ML concept. So I may not be really discussing machine learning in this course, but if you know a little bit of machine learning, I can give you a little idea how exactly the machine learning can be implemented into the Spark. You can consider that some core concept and maybe hello world kind of application. Some, of course, with demo, we will be trying to learn over here. And then we will also plan some project, a kind of a capstone project. So where we will implement one end-to-end pipeline, and we will be able to see that how exactly these things are working, correct? So that you get the real feel of, okay, the real projects and how exactly it should go, and etc. etc. Now, the Spark, though people nowadays use a lot onto the somewhere like a Databricks platform, that Microsoft Azure platform, even many of them are also using like a Google cloud platform. The Spark is like ubiquitous. So my concept while conducting this Spark batch was primarily that I wanted to focus, let people learn Spark well, let people understand Spark very well. And once they know the Spark, once they understand the Spark, once they use a Spark into the real applications, they can choose on which cloud platform they want to use the Spark. So to be very frank, I was not really planning to discuss this entire course onto the cloud oriented way, but still, I also had some of the requests that we will be people are using Databricks. Many of the people are also going for a kind of certification or something like that. So I just thought of adding a Databricks platform into this blog course. So we will be trying to learn the basic lakehouse fundamentals. We will be talking about the Databricks file system. We will be talking about what is that, Delta Lake UI, how exactly it is to be used. And we will be talking about how overall Spark implemented in Databricks. But again, I always believe that you should learn a technology, the core technology, in vendor independent mode. If you learn it in vendor independent mode, you have got like freedom that you can switch to any particular platform. You can just refer their little docs, or you can just refer their kind of little UI tutorials, and then that technology, you can use it anywhere that you want. So of course, it was not possible that I will cover each and every cloud platform. So I just thought of having some introduction to the Databricks, and where we will be doing a few practicals onto this as well. But as I said that my core focus of this blog course will be more of learning the Spark, and then you can just refer some of the tutorials of the respective vendors, and you can start exploring how to implement this concept into their particular UI. Correct? So this was a kind of a quick overview of what all this course was all about. Correct? I guess I have answered the majority of the questions over here, that what exactly we are supposed to talk or something like that. Still, if some of your questions are kind of unanswered or something like that, please feel free to send me a message. I'm already there on your WhatsApp group. We can discuss. Let me know if you have any questions, additional questions to be talked about, and we can handle that as well. Okay. I guess this is like 9:15. We had spent now kind of a good time. Let us call it a day for today. I'll be here for another 10-15 minutes. If you have any questions, queries, you can unmute yourself and you can talk. But I'm just stopping the recording over here. Thank you very much for attending the class, and see you into the next session. If you have any doubts, questions, feel free to ping me, tell me if you have any problems. Okay, bye bye. See you guys.